This presentation is about planning for failure. It's a story about error messages, and this is a quick overview of a philosophy to generating error messages. First thing, nobody really wants to talk about error messages. It's a little bit like dirty laundry. We just kind of wish they didn't exist. The fact that we have error messages seems somewhat of an embarrassment, and in some perfect world, they really shouldn't exist. So let's just try to get rid of them. Let's try to design a system that is so simple that it can't possibly have an error message. But of course, that's not realistic. Software is complex. A system is big and complex. It has a lot of internal rules. Some of those internal rules are documented, and they could be a place where people read the documentation, or not all of them will actually be documented. There's some that just come from convention. But what really is the cause that requires us to need an error message? Why would a user send an improper request to the server? Well, do users make bad requests on purpose? No, of course not. Every bad request is because the user didn't know it was bad. I mean, let's face it, it's not a lot of fun to go and send bad requests to a system and get lousy error messages back. If they knew it was an improper request, they would not have done it. And this doesn't matter if this is a user using a form on a web or is a programmer that is programming calls to a web service. There's a lack of knowledge. So here's one thing that I want you to consider. An error message is just-in-time documentation on what cannot be done. There is, in fact, some complicated reason why the request makes no sense, and the user didn't know that. But the error message can explain it. And in fact, it's pretty easy to generate an error message that has quite a bit of detail on the specific problem that was encountered. And here's another thing to consider. That error message is always 100% in sync with the actual code. Well, Now error messages can be quite useful. A good error message will give the user the information they need to know to either resolve the problem or at least stop making the same problem. It's going to save the time of the user, who doesn't need to search through wordy documentation. They've got a clear example right in front of them. But it also saves the time of administrators and support staff, because this user doesn't call support and doesn't, if all the information is there's nothing more to get from support staff. So you save your support staff. It also saves the time of the developer, because if this is done right, it can be done with minimal effort and can still be accurate. It increases the chance that the user will actually learn to use the system. They'll learn what they can't do, at the very least, and through that they'll gain an understanding of the system. And all of this makes the system more successful. So there's a whole lot of value in producing a good error message when a bad request comes in. But the system's complicated. Code is broken down into functions. There's no central place which understands everything that's going on. And putting together an accurate error message can be a challenge. But there's an easy way to do it. And to explain it, let me explain a very simple example. And this is some sort of a travel booking system. Someone named Alex wants to book a trip to Washington, and that system also needs to figure out whether a car can be rented. To determine that, we need to figure out if the driver's over the age of 25. To do that, we need to figure out what the birth date is. That needs the birth date to be parsed from a string. But this is where the program runs into a problem. It can't parse the date because whatever was entered in for birth date, it's been scrambled. Now, of course, we could design this program differently and check the date up front and all that kind of stuff. But what the purpose of this canonical example is to show you a little bit of complexity, a very, very realistic flow of information through the system, and how each part of the system doesn't have knowledge of the other and can't put together a nice error message. If any part of the system delivers an error, it'll be partial knowledge. Let me give you an example of some possible error messages. So first, consider that the date parsing method could send out some sort of message like this. The value blah doesn't appear to be a valid date. If you think about what the parser is doing, the parser has been given this string and asked to return a date, and it can throw an exception, throw an error, saying this is not a valid date. And that's perfectly true. But Alex is dealing with a bunch of dates. There's a bunch of dates, like the beginning date of the system, the ending date of the system. He looks through a few dates, doesn't find this date, doesn't understand the context that this is a birth date. Because remember, he was booking a trip, and it wasn't immediately clear to him that this would be in some way using his birthday. Similarly, we can go to the other end and consider the general most error. That's the sort of the bottom level. The trip to Washington for Alex cannot be booked at this time. That's also true. The problem is that this doesn't tell him anything about how to resolve the problem. The problem is that his birth date, that's either in his profile or in the request that was being made, is scrambled. And how would Alex learn that the birth date is the problem? So what I suggest is that the only way to resolve this problem is to give a list of error messages. Here we have the system responding, hey, the trip to Washington cannot be booked, the car cannot be rented, we can't determine that the driver is over the age of 25, we can't calculate the age from the birth date because the value does not appear to be a valid date. Now, this is something that the system knows, so to speak, doesn't know in one place, but this list of errors could be composed and returned. And if Alex received this message, it's very likely that he will realize that he has a bad birth date, and then he can address that birth date and rent the car and take the trip. This is constructed. Each of the methods knows a little bit about the problem. The topmost one knows that the date can't be parsed. The next one knows that the problem is something to do with the birth date. The next one knows that there's an age restriction on driving. The next one knows that it's trying to figure out a car rented from Hertz. And of course, finally at the root level, you've got the overall trip. Now, each of these can be put into exceptions. They can be thrown. Each level can wrap and rethrow. And if each routine can produce a good error message for itself, for what it is aiming to do, then ultimately a good error message can be composed. And so that's basically it. My main thesis is an error message cannot be a single error value from a list of possible errors. You can't have a list of, error number 150 and 151 and 152, this is what happened to you. That will give you only one possible level. But without having multiple levels in there, it's not possible to put together the story conceptually of what needs to be done. So an error message value is a list of strings. It's collected from different parts of the system and includes multiple levels of detail. I have more advice and presentations on how to do this. It's fairly straightforward, and I'll link you to some posts from my blog that document all of this. Thank you. Find these suggestions and more programming tips on the Agile Tribe blog. Find that at agiletribe.purplehillsbooks.com.